Hello again. Today starts the second half of the course, and we are going to go over problems from chapter 25. So this is problem set 6, chapter 25, which is current, resistance, and power. So let's take a look at the recitation problems and the homework problems. So the first problem, it's problem number 7. A 4.5 volt battery is connected to a bulb whose resistance is 1.6 ohms. How many electrons leave the battery per minute? So you can figure out the current easily enough, and that's coulombs per second. So you're going to have to go from coulombs per second to electrons per minute. So there are a couple of steps involved in that. The next problem is problem number 14. Can a 2.2 millimeter diameter copper wire have the same resistance as a tungsten wire of the same length? Give numerical details. So basically you have a copper wire of a certain length and a tungsten wire of the same length. You're given the diameter of the copper wire. Is it possible to come up with a diameter of the tungsten wire that will give you the same resistance? So remember, resistance is equal to the resistivity multiplied by the length and divided by the cross-sectional area. So the cross-sectional area is going to be pi r squared. You can just treat the wire as a cylinder. And you're not given the radius, you're given the diameter, so keep that in mind. But figure out what diameter of tungsten you would need to have the same resistance as a copper wire of the same length, given that its diameter is 2.2 millimeters. That brings us to number 18. Determine what temperature at which aluminum will have the same resistivity as tungsten does at 20 degrees Celsius. So you remember that equation, and so you look up the table that'll give you the resistivity of tungsten, the resistivity of aluminum, and also the temperature coefficient of resistivity for aluminum. And that'll give you enough information to solve the problem. That brings us to problem number 36. A 120 volt hairdryer has two settings, 850 watts and 1250 watts. At which setting do you expect the resistance to be higher? So remember, power is equal to V squared over R. We're given V, we're given P. So what does that tell you about R? And after making a guess, determine the resistance at the lower setting and then at the higher setting. That brings us to 43. How many 75 watt light bulbs connected to 120 volts as in figure 2520? So they're connected in parallel, so they each get 120 volts, can be used without blowing a 15 amp fuse. So basically, you're adding the voltages across the different bulbs together, or rather you're adding the currents across the different bulbs together until you get to 15 amps. And the last one to give you less than 15 amps answers the problem. So, keep that in mind. And, whatever number gives you less than 15 amps is what you'll need to, the highest number that gives you less than 15 amps is what solves the problem. And that brings us to number 53, the last of our recitation problems. An 1800 watt arc welder is connected to a 660 volt RMS AC line. So calculate the peak voltage. So we talked about the relationship between peak voltage and RMS voltage, and then figure out the peak current. So you have enough information there to figure out the peak current from that. Okay, so, and remember the relationship between power and voltage and current in an AC circuit, so in order to solve this problem. So that brings us to our homework problems that are due on Monday. So an electric device draws 6.50 amps at 240 volts. If the voltage drops by 15%, what will be the current, assuming nothing else changes? So again, assuming basically a constant resistance. And if the resistance of the device were reduced by 15%, what current would be drawn at 240 volts? So if you lower the resistance, what current do you get out? Number 20, compute the voltage drop along a 26-meter length of household number 14 copper wire used in 15 amp circuits. So the wire has a diameter of 1.628 millimeters. So we know the length, we know the diameter, which means we can figure out the cross-sectional area, and we know the resistivity because it's copper. We can look that up. That'll give you the resistance, and you're given the current. And so that'll tell us how to get the voltage drop. Problem 23, a length of aluminum wire is connected to a precision 10.00 volt power supply, and a current of 0.4212 amps is measured precisely at 20.0 Celsius. So it's an aluminum wire. The wire is placed in a new environment of unknown temperature where the measured current is 0.3818 amps. What is the unknown temperature? So basically the resistance of the wire has changed, and you can figure out what the old resistance is and what the new resistance is. And we know it's aluminum, and so we can look up the coefficient or the temperature coefficient of resistivity, and that gives us enough information to figure out the unknown temperature. And the last problem for the homework is number 44, an extension cord made of two wires of diameter 0.129 centimeters. So it's copper, and you know the diameter, which means you can figure out the cross-sectional area, and you're given the length, 2.7 meters or 9 feet, is connected to an electric heater, which draws 15.0 amps on a 120 volt line. How much power is dissipated in the cord? So you know enough information to figure out the resistance of the cord. And you know you're given the current, and so that should give you enough information to figure out the power that's dissipated in the cord itself. Now, it's not the power that's dissipated in the heater. That's something very different. You're just interested in the power that's dissipated in the cord. So keep that in mind when you're doing these problems. Okay, so if you have any questions, do not hesitate to email me and ask for help. All right, thank you very much and good luck.